Hello class, this is the video for section 3.4, and this section talks about building quadratic models from verbal descriptions and from data. Here are our learning objectives: build quadratic models from verbal description. In fact, this is an application of section 3.3. And then the build quadratic models from data, because we have to use a graphing calculator to graph certain data sets, and so we will not cover this in this class, okay, since the no calculators is required for this section. Okay, so building quadratic models, it could be any model. It could be with maybe fencing, a farming, you're fencing your farm, or it could be a revenue, it could be a profit, it could be in the engineering. I mean, building the bridge and the kind of cost involved, and so on and so forth. So it has a wide spectrum of what applications. All right. So in economics, we know that revenue, we denote R for revenue in what? In dollars, and it is defined as the amount of money received from the sale of an item, and is equal to the unit selling price P in dollars of the item times the number of X of units actually was sold. Okay, so in effect, the revenue R is given by what? The R, which is equal to X times what? P. Okay, now when this happens, we have what we call the law of demand, which states that P and X are inversely related. In other words, as one increases, the other one decreases. Now, if the equation that relates P and X is called what we call the demand what? Demand equation. And so when a demand equation is a linear or is a linear function, then the revenue model is a quadratic what? It's a quadratic function. And so we want to know that, okay. Now here we want to take an example. Say maximizing revenue, example 1. An electronics company has found that when certain calculators are sold at a price of P dollars per unit, the number of X of calculators sold is given by the demand function. So this is your demand function. Okay. Now we're going to do a lot of things here. Given this demand function, we want to find a model, okay, that expresses the revenue R, okay, in terms of the P. And what is the domain of that? Okay, so we said that this is a linear function. X, the demand function is linear, therefore the revenue function will be a quadratic. And then we use everything that we learned in section 3.3. Okay, and then part C, it says that what unit price should be used to maximize what? The revenue. In other words, we want to find what? The P, okay, that maximizes what? The revenue. If it's quadratic function, and if it has a maximum value, you know, that's going to occur at the vertex. And then D, if this price is charged, what is the maximum revenue? So whatever we get in C, we plug it into what? The revenue function and get that. And how many units are sold at this price? And then we want to graph R, okay, find the X and Y intercepts and what's happening since we know the domain. And then lastly, what price should the company charge for the product to collect at least 590,625 in revenue? Okay, so if the company want to know that if we want to get this revenue, all right, what price must be charged for this what type of calculator, all right, or that item? All right, so here are the solutions. One, part A says that what is the revenue? Okay, we know that revenue is given by what? X times P, where X is the demand function. So what we do is that we just multiply this by X, and then X is what? 18750 minus 125P, and then everything times what? Times P. Okay, and that gives us 18750 P minus 125 P squared. Now notice that this is the same as what? Minus 125 P squared plus what? 18,750. Okay. So this is the revenue function. This is right here. Okay. This is a quadratic function because it's in terms of what? Not in X, but in terms of P, the price. Okay. What's the domain? Okay. What's the domain? We know that the X demand function is definitely, it's non-negative because I cannot have a number of what X, which is a demand function. I cannot have it to be negative dollars. All right. It has to be positive. So X is what? X must be greater than or equal to what? 0. If that is the case, then we have to what? Solve this inequality. Okay. So in solving that inequality, okay, what do we get? We have what? We can rearrange that to what? 125p plus 18,750 greater than or equal to what? Equal to 0. Okay. Now, if it's greater than or equal to 0, then we want to solve this inequality. Basically, you have what? Minus 125p is greater than or equal to 18,750. Okay, then you divide both sides by what? Negative 125. This is p over minus, this is minus actually, minus 125. Now, when you divide, it changes to what? The inequality sign, what? It changes. And so you have p is less than or equal to, when you divide that, you get what? 70, actually you get 150. All right, you get 150. So we know that what it will be the domain, okay? What to be the domain of what? Of this function. Okay, the X, we know that P, the price is definitely is what? Greater than equal to 0. And then we just found that the P is also less than equal to 150. So therefore the domain of what? R, which is the revenue, is going to be between P is what? Is greater than, is less than equal to 150 and greater than equal to what? Equal to 0. Okay, which is the same as taking the revenue. We could have done this by taking the revenue. I will let you try that. Taking the revenue function, which is here, minus, we know that the R, the revenue in terms of P, must be greater than equal to 0, for sure. Okay, your revenue could be 0, or if you don't sell anything, it could, yeah. So you can solve this inequality, 125p squared, okay, then plus 118,750 times p greater than equal to 0. When you solve this, you're going to get the same thing, 150, and then less or equal to what? P is between that. So therefore, again, this is your domain. Okay, that's your domain. All right, let's go to part C then. Excuse me. It said, what unit price should be sold to maximize what? Revenue. By the way, is the quadratic function, is that we're going to have a maximum point? Okay, let's figure out here. Now we can rearrange this as we said. This is okay. We can rearrange that into minus 125p squared plus 18,750 times p. Okay. Now if you see your A is what? Is negative 125. It's what? It's less than. So since, okay, your A is less than 0, the R has what? Maximum point at what? The vertex. Okay, now the vertex, remember, it's in this case your vertex, which has what? H and then K, from my section 3.3. That is basically, this is in this, the function is in terms of P. So P, okay, which is in case your X, this is your H. And then where A is equal to negative 125 and B is equal to 18,750, what do we, let's evaluate that. This is equal to minus B, 18,750, okay, divided by 2 times A, which is minus 125. So you get what? 18,750 divided by, that's 250. Okay, divided by 250. And when you divide this, you get what? 75. Okay, you get 75. All right. So it means that the what? The revenue, okay, is maximum at what? The P price, which is what? $75. So if the company charges what? $75 for that commodity or that item, okay, it's going to maximize my revenue. Okay, that would be the revenue for that. So they said, at what price should the company charge to maximize revenue? And that price is what? 75. So what is the maximum value then? What's the maximum revenue? That's the next step. Maximum revenue is given by what? When we substitute the price, which is P equal to the 75, into the revenue function, which is minus 125 P squared, okay, so 75, then plus 18,750 times what? 75 times 75. Let me erase that. Okay. Now, when you do that, if you want to evaluate, okay, you get what? $703,125. Okay. So this is my what? The maximum what? Maximum revenue. Okay. So in actual fact, in terms of section 3.3, this is the vertex. This value here is your K, and then your H is the what? Is the 75. So the vertex on the graph of the revenue is going to be what? The 75, comma 703,125. Okay, you see how these two sections are related. So you have for 75, okay, and then that. Okay, perfect. So then E, how many units are sold at this price? How many units are sold at this price? Okay, how do we define that? Okay, how do you find this? Well, the demand function, okay, we know that P is equal to $75. So how many calculators should be sold if the manager wants to know how many calculators should be sold so that we maximize the revenue to get 703,175 for this type of calculator. Okay, so the demand function was given, and therefore we basically plug in this what? $75 into that. Okay, and then when we do that, we have X is equal to 18,750. Okay, minus 125 times what? 75. And then when you do that, you have what? 9,375. So it means that if the company sells at the price of the calculator, sell each one at $75, it's needs to sell 9,375 of that calculators to get the maximum what? Revenue. But remember, revenue is not profit. So they have to factor in the cost, subtract the production cost before they can think of the profit. But that would be the maximum revenue. It gives a good idea for the company to plan. Okay, how much should we charge this? How much should? So if it means that, now remember, if they decide to charge this price at what? At 70, at say $80, the revenue is going to be less because the graph has maximum is going to be. So at the peak here, that's where we have, if they sell 75, if they charge 85, anything past what? Before, okay, anything past what? $75, all right, it's going to, the revenue is going to decrease. Okay, so take note of that. All right, so what is a graph? What's a graph of this function? Okay, what's a graph of this function? Now, to graph this, we need to find the X and Y intercept. At least we know the points. So the question is, how do we get these values? Okay, these are the X intercepts. what's the y-intercept? Okay, so what's the y is equal to the r of p. So y is equal to the r of p. That's a function. And so when p is equal to 0, what is y? That's the y-intercept. Okay, you're going to have so revenue at 0 is what? Is 0. Because what's the function? Remember, the r of p is what? Minus 125 p squared plus 18,750 times p. So if p is 0, this is 0. So x-intercept is 0. Now, what is the y-intercept is what? At 0, 0. So 0, 0. That's the point. Now, what are the x-intercepts? Well, when you set this to 0, so that means that if we set this equation to 0, okay, we have what? 1 minus 125 p squared plus 18,750 p equal to what? 0. So we solve this inequality. So this quadratic equation, we factor, okay, let's factor, what do you call it? If you factor 125 out of, what do we get? See, so that is, if I factor p out, okay, I can even factor p out, or minus 125 out of this, okay, then I have what? P, and it'll be p minus, okay, so if we divide the 18,700 and what? 750 by 125, you get what? 150. Okay, that's set to 0. So it means that either you have minus 125 p equal to 0, or p minus 150 equal to 0. So you have for p is equal to 0, or p is equal to 150. All right, so that's why we have the x-intercepts at the origin. So if I want to grab this, I plot my x-intercepts. My vertex is what? 75 and 700,125. So it is maximum. So there's a maximum point there, and the graph comes down, okay, and then hits that 0, 0. It doesn't have the negative axis. So remember that, because we don't want to have a negative what? Revenue or price, or and the number of what? Commodity, or the calculators. So this is the graph of that. Okay. Now in this graph, the question says just graph that. So the last part says that if your R is what? Is equal to this. Okay. He said that draw this on this in same plane. So we'll see that in the next graph, the next slide. But say we find where the graph intersects by solving this equation. When you equate these two, your R is equal to that, and then R of P is also equal to that. So if you equate these two, we have what? We have this. So it means that we need to solve this what? This equation. Okay, so let's subtract 590, 625 from both sides. Okay, so we have minus 590, 625. So that gives us 0 equal to, okay, let's see what I have there. Very good. 0 is equal to minus 125 p squared plus 18,750 p minus 596 what? 625. Okay, if we multiply through by what do you call it? If you multiply through by negative 125, multiply through by negative 125, okay, what do we get? Okay, let's see. We have that. If you multiply 2 by 125, then you have this equation here. You can have p squared, okay, minus 150 p, then this will be plus 4,725 equal to 0. So when we factor this, okay, we want 1 times, so 4,725. 2 factors, when you add, you get what? you get 150. You have what? 45, and then what? 105. Now both of them are negative, so that when you add them, you get what? Negative 150, which is right there. So P minus 45 and P minus 105. Okay, so you set each of them to 0. Okay, you set each of them to 0. Then you have for P is equal to 45 or P is equal to 105. So it means that when you have this line, which is like draw the line, the horizontal line equal to that value. Okay, so if you draw on the graph, they intersect at this what? At these values of what? X. So with this one we see in the next slide. Okay, so it means that the graphs intersect at these points, 45 and 596.25. As you can see, this is the line. This is the line, the R of X, or if you like, Y is equal to 596.25. Okay, so that's what you said that we should do. So based on this, what can we say? It means that from this, the company should charge between what? $45 and $105 to earn at least that revenue, that amount in revenue. Okay, so that brings us to the end of this example. Now here's the second one. This is maximizing the area enclosed by a fence. So you are doing gardening, and then you decide to see how you want to fence your garden, and you are given the fencing yards. You have 2,500 yards of fencing material, and then it's enclosed in the rectangular. So remember that in the rectangular what field. Okay, so what are the dimensions of the rectangle that encloses the what? The most what area? The most area, and that was the maximum area. Okay, so here's a diagram. So this is my rectangular what? Garden, all right, farm, labeled as X. The length is X, then the width is W. Okay, we know how to find the area of a rectangle. Well, the question is that what is the area? Okay, the available fencing represents what? It goes around this. Okay, it goes around that. So that is what? That is called the perimeter. Okay, so the perimeter of the rectangle is actually the what? The 2,500 what yards. Okay, so the question is that we want to find right that. If the perimeter, usually we use P for that. So P is equal to 2,500. Now for this rectangle, what is the perimeter? That is what? The distance around it. The perimeter, we have X plus X, so that is what? 2X. And then W plus W, that is what? 2W must equal what? The 2,500 yards. Okay, so this is an equation. All right, then the area is given by the length times the width. Okay, so the length is X, so in this case will be X times what? X times W. All right, so for us to go further, we need to express the area in terms of one variable. It has two, so we can't solve it in that way. We have to get two equations and solve them simultaneously, but we want to express this as what? In terms of one of the variables, X and then W, one of them, one or W. Okay, X or W. So here, now let us express S in terms of a single variable and solve first the equation for W and substitute into the what? Into the function. So what we have there is that we are given the perimeter was what? Was 2X plus 2W equal to what? 2,500. Now if I divide both sides by 2, okay, this by 2, this by 2, this by 2, I get X plus W is equal to 1,250. All right, so let's solve for W and substitute into the area function here. So it means that the W is equal to 1,250 minus what? Minus X. Well, so therefore the area A is equal to what? X times W, and W is what? 1250 minus X. Then when I express this, that gives me 1250X. If you distribute the X over, minus what? S squared, which is the same as if you rearrange the 1250 times what? Times X. So this is the area. Now the area is in terms of what? X. And we note that this is what? This is quadratic. This is a quadratic function. Okay. So what we do is that is where we have the A. In this case, your A is -1 and your B is what? 1250. Okay. So the question is that we want to what? Find, remember, is it find the what? The dimensions, that is find the values of X and W so that we have a maximum what? Maximum area. Okay. So I want to just find, let's find the domain of what? Of the X, okay? The domain of the area, okay? So we know that A of X is equal to -X squared, okay? Plus 1254 times X. Some of us have forgotten how to solve what? Inequalities. So I just chip this in. Then this, if I know this, I can find the area, sorry, draw the graph of that. Okay, by the way, this is quadratic, and since what? A is what? -1, which is less than 0, it means that the area has what? Has a maximum value. Okay, so take note of that. Now, we know that the area must be what? The area in terms of X must either be greater than or equal to 0. All right, so we pick this inequality, minus S squared plus 125X, and then we solve this inequality. Well, first, we will consider the equal sign. Whatever, no, irrespective of what inequality sign over here, we just solve, take the inequality and get a number line and check and test, okay? That's how we solve what? Quadratic inequalities. So we have minus X squared plus 1250, X equal to what? 0. So let's solve for X and factor negative X out. Negative X out gives me X minus 1250 equal to 0. So then you have for minus S is equal to 0, or X minus 125 is equal to what? 0. And that gives me X is equal to 125, and then S is equal to what? Is equal to 0. So this gives us what? The number line, all right? We know that, of course, remember, X must be greater than or equal to 0 because this is a dimension. It cannot be negative. It's non-negative variable, okay? The length and then the width, they are both what? Must be greater than or equal to 0. So we're going to have for 0 here. And you cannot say it's all real numbers, okay? Because it might be, it doesn't have to, because of your fencing, you have only what? 2,500 yards. So it cannot be to infinity. So that's why we have to find the domain of this. So let's put 125 here. And then we're going to test. Let's say you have 125, what do you call it? 250 yards. Oh, that's the whole thing. Okay, what's happening that we test this on this inequality. Okay, so if I use, say, 1, if I pick X is equal to 1 here and substitute into this inequality, okay, that gives me minus 1 squared plus 150 times 1. Is it greater than or equal to 0? Well, you have for minus 1 plus 125 is greater than 0. So this is true, okay? So it is positive, so that is true. Now, if you pick anything after here, it's going to be negative. It's not, it is false. Okay. So the domain, okay, domain of the area, okay, A of X is what? S is between 2,500 and is greater than or equal to what? It's equal to 0. Okay, that gives me an idea if I want to what? Get this graph, which should be positive and negative, positive of only the positive axis, then this is, if I put my 125 here, this would definitely be my x-axis. That would be my my s-intercept 0. Then there is a value so that we have a maximum, which we are here to find. Okay, to maximize this, we need to find that value. So the question is, what is that value? And then what is W? So that we can get the dimensions. All right, so here you have A of x is equal to that. Okay, now because it is not, A is negative, it has a maximum point on the graph. So the question is that the maximum point occurs at where your x is equal to what? Is equal to that. Okay, we know that from here, your A is what? -1. Your B is what? 2,250. Okay, so when you substitute that, this will give us, you have minus 1,250 divided by 2 times what? 2 times -1. And that will give us what? 625. Okay, so it means that your x is what? 625 yards. So the question is, what is what? What is W? Okay, remember the W is equal to 1250 minus what? X. We can get it from the previous slide. So that is 1250 minus 6 what? 625. That is also what? 625. Okay, so that is yards. So this tells me that the area is maximized. We get the most area when the length is what? 625 yards, and the width is also what? 625 yards. Okay, so we put this together in the next slide and say that so the question, what's the maximum value of the area? What's the maximum area? Basically, we substitute that into this, okay, into the function. We have what? Minus x squared, so 625 all squared, then plus 125 times x, which is what? 625. Then when we evaluate this, we get 390,625. So in effect, what's the conclusion then? The largest rectangle that can be enclosed by 2,500 yards of fence has an area of what? Of this. And what are the dimensions? Dimensions are what? 625 yards by what? 625 yards. Okay, so this is your X, and then that is your W, or W and X doesn't matter because they have the same value. All right, last example is a minimizing a marginal cost. Okay, the question is that the marginal cost C in dollars of manufacturing X smartphones in thousands is given by this function. So there's a company who produces what? Smartphones, and this is the what? This is the cost. The marginal cost, what means that it is the cost for producing an additional what? Smartphone. So if the marginal cost is say 100, and we'll say that what's the margin? What if the cost of producing say 100 units, okay, is say 20,000. All right. So what's the cost in producing the 101st? That's if you add one more, what would be the cost? That is what the marginal cost is about. Okay, so the question is how many smartphones should be manufactured to minimize the marginal cost? And what is the minimum marginal cost? Okay, so we do this. Well, how many smartphones? Okay, well, how do we know that this marginal cost function is what is minimized or has a minimum value? Of course, you know that A is what? Is 5, and your B is minus what? 200, and then your C is what? 400. Now your A is actually greater than what? 0, and therefore C has what? Has a minimum. As a minimum what? Minimum value. Okay, so this occurs is in that the minimum value of C, it occurs at what? Your x is equal to minus b over what? 2a, which is the vertex. And so let's find that this is actually negative of what? Negative 200, okay, divided by 2 times 5. So you get positive 200 divided by 10, which is what? 20. Now remember, x is in thousands. So it means that there should be what? How many smartphones? There should be what? 20,000. Okay, because the question says that the what they call the x is in thousands. So 20,000 what? Smartphones should be manufactured to what? Minimize the what? The C, the marginal cost. Okay, so it means that if we don't manufacture this number of what do you call it, smartphones, if you manufacture less, the cost will be higher. If you manufacture more of 20,000, the cost will also be higher, because if it's minimum, it's this is how the graph is like. So your minimum occurs at what? 20 of what? Something value of x, which we can find later. Okay, perfect. So the question is that what's the minimum marginal value? What's the minimum marginal value? Of course, that is when x is equal to what? Equal to 20. Okay, you don't plug in 20,000 because x is said in thousands. Okay, x is equal to 20. And what is that? So you have what? C of what? 20 into the function. That gives me 5 times 20 squared minus 200 times 20 plus what? 400. So let's calculate that. What is 5 times 400? Because 20 squared is 400 minus 200 times 20 plus 400. Okay, this is what? 400 times that's 2,000. Okay, minus 4 times that is another what? 2,000. Okay, sorry, 4. This is 4. Okay, because you have what? That's 2 times that's 4. Okay, and plus what? Plus 400. Okay. Okay, let me get my calculator well and evaluate that. So you have, I hope I did that correct. Okay, so 5 times 400 and then 200 times 20 is 4,000. So that gives me, okay, that gives me, you get what? Minus 1,600. Okay, that gives me minus 1,600. Okay, so let's go back and look at the function. We have 5x squared minus 200x plus what? Plus that. Okay, so why is that? Why is it getting negative there? Okay, we're getting the negative because it's what? This is a marginal cost. All right, so it means that we need to what? Maximize what? That value. Okay, so the minimum marginal cost occurs at when x is equal to what? 20. Because let's make sure that's what we got. We got what? It was 200 divided by 10. And that is what? That's 20. So we plug that into the what? The marginal cost function. And that should give us what? Oh, 200, 1,600. Okay. So it means that this is it's set in dollars. So the marginal cost will be what? The marginal cost will be this price. Will be that much of value. Okay. So that brings us to the end of this section. Thank you. I'll see you next time. Bye-bye.